In Part 4 of Power Plant, we will discuss N1 RPM, electronic engine control, reverse thrust, and vibration monitoring. Let's begin with N1 RPM. N1 RPM is the primary thrust indication for the General Electric engine. N1 is displayed on ICAS as part of primary engine indications. Normal operating indications for N1 RPM are displayed by white digital and vertical indicators. The digital indicators show numerical value, while the vertical indicators move to show relative value. Maximum N1 is displayed as amber lines. Maximum N1 displays the maximum thrust rating for the engine. The N1 indication remains white when maximum N1 is reached. Reference N1 indicators display the reference N1 RPM selected by the FMS. The command N1 indicators display N1 RPM commanded by thrust lever position. When the engine is stabilized, actual N1 RPM equals the command N1 RPM. As the thrust levers are moved, the new command N1 RPM is displayed. Now, let's discuss the electronic engine control. The engine control system is an intricate system of sensors and actuators that are coordinated through the EEC. Each engine has a multi-channel, full-authority digital electronic engine control, or EEC. The EEC automatically controls forward thrust, reverse thrust, idle, and overspeed. The EEC receives inputs from the thrust lever, flight management computer, air data computer, and engine sensors. Thrust lever position is transmitted to the EEC electronically with no mechanical interconnection. Controls for the EECs are located on the overhead panel. The EEC has two control modes, normal and alternate. The EEC uses the normal mode as its primary control mode and uses the alternate mode as a backup. In the normal control mode, the EEC uses N1 RPM to set thrust. Based on thrust lever position, the electronic engine control calculates an N1 value between idle and maximum N1. The EEC commands the fuel metering unit to adjust fuel flow until actual N1 RPM equals calculated N1 RPM. As the thrust lever moves from the closed position to full forward, the EEC increases thrust from idle to maximum N1. At the full forward position, thrust is limited to maximum N1. When the engine is stabilized, the EEC keeps thrust constant independent of outside air temperature and pressure changes. A fixed thrust lever position can therefore be used throughout a climb. Normal mode. The EEC adjusts thrust automatically for nacelle and wing anti-ice and airplane pressurization bleed requirements. In the alternate control mode, the EEC uses N1 RPM to set thrust. In the alternate mode, the EEC does not provide thrust limiting. Maximum N1 may be exceeded as the thrust lever nears the full forward position. In the alternate mode, the EEC requires thrust lever adjustments to maintain desired thrust as environmental conditions and bleed requirements change. The EEC automatically transfers control from the normal mode to the alternate mode if a fault is detected and the EEC cannot control the engine in the normal mode. Pushing the EEC mode switch manually selects the alternate mode. When the EEC automatically transfers control from normal mode to alternate mode, thrust does not change. However, when the alternate mode is manually selected, thrust increases. Moving the thrust levers aft before manually selecting the alternate mode prevents exceeding maximum N1. If control for any EEC transfers to the alternate mode, the auto throttle disconnects automatically. The ICAS advisory message Engine EEC mode is displayed when control is in the alternate mode. The EEC alternate mode light also illuminates.
The ICAS caution message, Engine Limit Protection, is displayed when the EEC is in the alternate mode and command N1 exceeds the maximum rating. The ICAS advisory message, Engine Control, is displayed if one engine EEC is not fully functional. The EECs have redundant systems. A loss of redundancy may degrade EEC operation. If 3 or more EECs are operating in this degraded condition, the ICAS advisory message, Engine Controls, is displayed. The engine control and engine controls messages are inhibited in flight.
Question. Answer B is correct. Answer B is correct. Question. Answer A is correct. Answer A is correct.
The EEC automatically selects minimum idle during most phases of flight and ground operation. Approach idle is automatically selected for all engines when flaps are in the landing configuration, or for each engine when nacelle anti-ice is on. Approach idle decreases engine acceleration time for go-around. It is maintained for 5 seconds after touchdown, at which time minimum idle is selected. The ICAS advisory message, Idle Disagree, is displayed if the idle setting of one or more engines does not agree with the idle setting commanded by flap position. The ICAS advisory message, Engine Low Idle, is displayed if the engine is not in approach idle when the flaps are in the landing configuration or nacelle anti-ice is on in flight. EEC automatically prevents rotor overspeed. If N1 or N2 RPM approaches overspeed, The EEC commands the fuel metering unit to reduce fuel flow to prevent overspeed.
The ICAS advisory message, engine RPM limit, is displayed when N2 RPM reaches the operating limit. This indicates the EEC is preventing RPM from exceeding the operating limit, even though the thrust lever is commanding more thrust.
Question. Answer C is correct. Answer C is correct.
Now, let's look at reverse thrust. Reverse thrust is accomplished by directing fan air through fixed cascade reversers. Bleed air from each engine powers its respective thrust reverser. To deploy the thrust reversers, the airplane must be on the ground. Reverse thrust levers are located on the forward side of the thrust levers. The forward thrust levers must be moved to the closed position before the reverse thrust levers can be raised. The reverse thrust levers can be moved from the down position to idle detent to full reverse. When the reverse thrust levers are in the down position, the reversers are locked in the stowed position. Raising the reverse thrust levers to the idle detent applies bleed air to the reversers. The reversers unlock and move aft. When the reverse thrust levers are raised to the idle detent, the forward thrust levers are locked in the closed position, the autothrottle disconnects, and speed brakes deploy if the speed brake lever is down. When the reversers are unlocked, amber reverser status annunciators are displayed above the N1 indications. When the reversers are fully deployed, the reverser status annunciators change color to green. The thrust lever interlocks release when the reversers are fully deployed. Moving the reverse thrust levers to the full reverse position applies maximum reverse thrust. The EEC automatically limits maximum reverse thrust using N1 RPM. Moving the reverse thrust levers to the idle detent reduces thrust to idle when reverse thrust is no longer required. Moving the reverse thrust levers to the down position commands the reversers to move forward to the stowed position. When the reversers move forward, the reverser status annunciators change color to amber. When the reversers are locked in the stowed position, the reverser status annunciators are no longer displayed. If a reverser inadvertently unlocks and deploys, the thrust reverser system automatically applies bleed air to the reverser to stow and lock it. The ICAS advisory message, engine reverser, is displayed when a fault is detected in the reverser system. If displayed in flight, the reverser may deploy if the reverse thrust lever is raised. If displayed on the ground, the reverser will deploy normally.
Question. Answer B is correct.
Question. Answer C is correct.
Now let's discuss vibration monitoring. The vibration monitoring system monitors engine vibration levels to track rotor imbalance. 2 accelerometers are located on each engine. The accelerometers sense vibration caused by N1 and N2 shaft rotation. Engine vibration indications are displayed on ICAS as part of secondary engine indications. Vibration level is displayed by white digital and vertical indicators. The digital indicators show numerical value, while the vertical indicators move to show relative value. The vibration source annunciator is displayed above each digital indicator. The annunciator indicates whether fan, N1 turbine, or N2 rotor vibration is being displayed. The source with the higher level is automatically displayed. If the vibration system detects a fault and cannot determine fan, N1 turbine, or N2 rotor vibration, the indication for the affected engine displays broadband vibration. Broadband vibration is the engine's average vibration level. Display indicator is displayed as a white line on the vibration indication. If a vibration level reaches the display indicator, all vibration indications are automatically displayed.